Hello and welcome back to yet another RxM Cloud Native Short Take. My name is Iliyan Petkov and today we're going to talk about Kubernetes DaemonSets. We are going to discuss what DaemonSets are, what is their use case, their purpose in Kubernetes environments, how we create and manage them. Kubernetes DaemonSets are controllers similar to deployments, stateful sets, or job. Their main goal is to manage and make sure that exactly one pod instance of a specific pod is running on every single Kubernetes cluster node. Every time we scale our cluster horizontally by adding an additional cluster nodes, DaemonSet will create a new pod and the scheduler will start it on the additional node added to the Kubernetes cluster. Similar, when we scale down the Kubernetes cluster and we remove nodes, the pods running on that node will be garbage collected by DaemonSets. Alright, so for what purpose we use then the DaemonSets? Usually we need DaemonSets when we must make sure that exactly a single instance of a pod is running on every single node inside the cluster. Such use cases are when we are deploying networking or storage plugins, logging, monitoring, or security agents. DaemonSets, as most of Kubernetes resources, are creating by specifying a YAML document. Let's see how this is actually working in practice. For this, we are going to create a small Kubernetes cluster ad hoc using Minikube that will consist of two nodes. We'll be using the profile name demo. This is any arbitrary name that we can specify. And we are going to use the latest version of Kubernetes. For creation of the Kubernetes cluster, we are going to use a container runtime. In this case, that will be Docker desktop. Creation of the cluster will take a couple of seconds, so we are going to fast forward. Alright, Minikube just has created our Kubernetes cluster and configured our kubectl client. We can check that by using kubectl get nodes, and as you see, we have small two-node cluster consisting of a control plane node and a worker node. Both of them are in ready state. Next, let's apply the DaemonSet spec in order to create it. kubectl apply fund. All right, so our DaemonSet has been created. And if we take a look inside the namespace kubesystem where the DaemonSet has been created, we'll see that indeed DaemonSet exists. It has two desired replicas. Currently we have two of them are ready, both are up to date, both are available. We haven't specified any node selector, so that's one is none. And the DaemonSet has been created 22 seconds ago. But a couple of seconds has passed. Now let's clear the screen and look at the pods that this DaemonSet manages. We are showing the pods using kubectl get pods in the kubesystem namespace, and we are selecting the pods by the label that has been assigned to them during the creation. We are also using the -o flag, -o white, so that will show us also additional information about the nodes where the pods has been created. Currently, we have two nodes in our cluster, and we have two pods created by the DaemonSet on every one of them. Now, imagine a situation where we want to scale horizontally our Kubernetes cluster because we need more compute resources to deploy or memory resources to deploy more workloads. This is easily achieved using Minikube by using Minikube -p, the profile of the Kubernetes cluster that we want to modify, and then node add. Let's quickly verify that. If we use kubectl get nodes, we'll see that now our Kubernetes cluster consists of actually one control plane node and two worker nodes. Let's see what is happening now after this change with our pods managed by the DaemonSet. As we'll see, we still have the original two pods created on the control plane node and the first worker node, but now we also see that a new pod has been created on the newly added nodes to our Kubernetes cluster. That's great. Now, let's see what will happen if we scale down the cluster by removing one of the nodes. Again, this operation will take a couple of seconds. Okay, so it's ready. And if we get the pods managed by the DaemonSet, we'll see that the output shown will not be changed. It will take a couple of seconds for this information to be updated. So fast forwarding a couple of seconds. All right, so as we see, eventually the pod has been garbage collected by the DaemonSet, and again we see only 2 pods for each of the nodes in our Kubernetes cluster. So if we delete the DaemonSet, every single pod that was managed by the DaemonSet will also be deleted. So let's quickly take a look. And we see that there are no more pods left. Kubernetes jobs are just one of the things that we teach at RxM in our classes. If you want to participate in any of them, please visit us in our webpage rxm.com, where you can find more than 200 classes that we offer in our course catalog covering various technology topics. You can also build a custom class using our course builder, including any topics that you might be interested in. I've been Iliyan Petkov at RxM, and this has been another RxM Cloud Native Short Take. Thank you for watching, and see you the next time.